now. Thanks.
All right, thank you so much, Anna, for inviting me. It's been a long time, and we were young, free and single, I think, way back in 2004, and now we're old, married with children. So we've changed quite a bit since then. So when I met Anna way back in 2004, I just started my research in humpback whales. And so what I'm going to do is, can everyone hear me and see me okay? It's just I seem to have frozen on the screen. I'm just going to double check that I'm all good with everybody. If someone can give me a thumbs up, that would be great.
Yeah, you are. You look, well, to me, your video is frozen. So maybe turn your video on and off again.
Yeah, I think I'm going to turn the video off. So let me just stop sharing for a second. Stop my video. And the problem is my internet may be crashing.
Okay, well, maybe everyone, if everyone could video themselves, just because it might help with connectivity, that'd be great. And then we'll just keep you going, Bex, if we can.
Okay, all right.
Oh no, now it's not working at all.
Yeah, I can hear you, but my screen's frozen. So I'm going to just come out and come back in again.
Okay. Okay. Oh, the joys of Zoom. For anyone that might be joining at this very moment, our speaker is having connectivity issues. She'll be back in just a moment. Just hold the fort. And hello, Saskia from University of Norway, the Arctic University of Norway. That's very cool. Anyone else from international places? Tell us in the chat bar. Joaquin, is that how you spell welcome in Norwegian then? Those are two L's. Ah. Oh no, where is Beck? Oh, sorry, Joaquin. I love your English. So anyone that's just joined, Beck, our speaker, is just coming back. I think her computer just crashed. So just read an email or two, have a little cup of tea. She'll be back any moment.
All right. So as I was saying, way back in 2004, that's when I started my research in humpback whales. And I've been pretty much working on it ever since. But what I've started to get into a bit more recently is whether or not these animals can be considered to be socially intelligent. So Anna told me that to pitch it, this is a fairly relaxed group. I'm sure there's lots of people with lots of different expertise that are listening in. So I'm not going to go into a lot of detail about sociality within animals, but I'm just going to present a little bit about different types of social interactions with animals. And when animals get together in a group, the problem is that they compete over resources. And when they compete, obviously there's conflict within those social groups, and that conflict can be quite costly. And the obvious costs are, if you fight, there's potential for injury. If you have that resource and someone fights you for it, there's a potential that you could lose that resource. And then, of course, while you're within that conflict interactions, there's obvious metabolic and energetic costs. But we of course know that animals do tend to live in social groups. So here you can see that even though there's conflict within those groups, they do tend to group together. And animals will form social groups if the benefits of sociality outweigh the costs. So we're in a group and we have conflict, and there needs to be some way of resolving that conflict. And the way that animals tend to resolve conflict is to assess each other's resource holding potential. Now, there's two factors that contribute to that resource holding potential. The first factor is pretty obvious. It's your relative fighting ability. And that's based on your size, your weight, your age, or your rank. So whether you're an alpha or a beta type male, and then your experience as well. So clearly the more fights you've had, the more experienced you are. And on top of that, there's the motivation to fight. And obviously resource holders have a much higher motivation to fight versus a resource intruder that's trying to grab that resource. So those two factors add up to each other's resource holding potential. So in terms of competitor A, if his resource holding potential outweighs competitor B, he will fight. In terms of competitor B, same thing, competitor B will withdraw. And this way that they can minimize the risk of injury. And what they do is they assess each other's resource holding potential, and that's called mutual assessment, but they can also self-assess as well. So you can self-assess your own size, your own weight, your own rank, and your own experience. So that resource holding potential is a combination of both mutual and self-assessment. So within stable societies, I know these are the ones that tend to stick together. In stable societies, you tend to have animals, they remain in the same social group, and they remain there during their lifetime. So within these stable societies, if there's a conflict about to happen, the two competitors will assess each other for their resource holding potential. And the first type of information that they will get from each other is the immediate information. So they will size each other up. They will decide on their relative size, whether or not each other has weapons and maybe the size of those weapons, like horns or something like that. And they'll also be able to assess the relative age. The benefit of being in a stable society is, of course, because you're constantly interacting with each other, you can also assess each other's experience. So you should be able to remember past encounters that you may have had with your competitor. You can then assess your relative experience compared to its relative experience. And you can also assess third-party relationships. For example, I know that that competitor had a fight with another competitor and he won that fight. Therefore, I can determine whether or not I think I'm going to win a fight against him or whether he's going to win a fight against me. Now, the benefit of being in stable societies is that time is on your side. You've got a lot of time to assess these relationships. You've got a lot of time to remember the different experiences that you had. And because there tends to be a relatively small number of animals within that group, and you tend to stick together within that group, you can basically remember all the information that you need to remember to help you decide whether or not you're going to outcompete your competitor for that resource. I don't want you to look too much detail in this diagram, but this shows the complexity of the relationships inside stable social groups. The two main things that animals think about is with whom should I fight and with whom should I cooperate. And so within that, you've got the social properties of the group as well as the social properties of the individuals. Then you've got these didactic relationships within there. Some animals will tend to cooperate more with other animals. Some animals will tend to fight more with other animals. And then you've got the social interactions and events that feed into that. And all of these facets develop quite complex social relationships within stable groups. And this social complexity leads to social intelligence. Because these animals have to compete and keep up with all these different relationships, they have to be socially intelligent to be able to do this. And this tends to lead to quite complex social relationships within these groups. For example, different ranks and different matrilines, as you can see in this wolf group. They tend to distribute each other between the highest rank right down to the lowest rank. Each animal can assess where he is in terms of rank. Each animal then knows, based on his age, based on who his mother was, where he stands within that group. And he's able to keep up with the relationships with all the other wolves in that group. And to do that, you need quite a big brain size. So the hypothesis here is that as the brain size increases, so does the group size, because then you're able to keep up with more and more relationships within these groups. You can see on this graph that humans, their average social group size is roughly about 100, and the size of their neocortex is about 4 times the size of the rest of their brain. In other words, they've developed quite a large brain size to be able to keep up with all these different social relationships. And that's the social brain hypothesis. Now, all of this so far is based on stable groups, but of course we have other non-stable societies out there. And one of the most famous examples of that is the Fish and Fusion Society of Dolphins. And here the group structure is not particularly stable. Animals tend to associate more with other animals, but they'll split off and join with the main group. They may disappear for a few days, they may come back. They've got lots and lots of different non-stable interactions going on. So their group dynamics are quite different to stable societies, but there's still conflict occurring within these non-stable societies. So as with the stable societies, they can still gather immediate information from their competitor. They can still pretty much assess the relative age of that competitor, whether or not he has weapons, the size of his weapons, the relative size of the competitor, and things like that. But the problem here is with experience. Because there's fewer repeat interactions, because there's more individuals to manage, that leads to high levels of social uncertainty. So although they have the immediate information there, they maybe don't have that experience to be able to help assess their relative resource holding potential. The problem here as well is that time is not on your side. Because you're constantly splitting and joining from the main group, you're not there, you're not stable, and you don't have a lot of time on your side to be able to really assess these different relationships. So because of that, even though these non-stable societies were considered to be less complex, in fact, the social intelligence hypothesis suggests that this social uncertainty actually leads to social intelligence as well. So it's a different type of social intelligence needed to manage these relationships. Not only do you have to manage relationships within your groups, but you also have to manage relationships with outsiders and with maybe other groups as well. So here in this diagram, you can see that this animal has to manage his within group interactions. Then he's got to manage interactions with outsiders, seeking breeding opportunities, seeking territorial opportunities. He's got to manage contests between outside rivals and things like that. And all of this requires this animal to have social intelligence as well. So I'm going to take a bit of a left turn and go into the humpback whale, who is not considered to be a socially intelligent whale. The humpback whale is a pretty common large marine mammal. He's one of the best studied marine mammals. He's about 13 meters long and weighs about 30 tons. And anyone that's gone whale watching, you'll find that you can pick him out amongst the other whales because he has a distinctive hump. He has characteristic very long pectoral fins, and he's got an individually pigmented ventral fluke, which allows us to individually ID each animal. He's dispersed throughout the world. So here you'll see a number of different humpback whale populations. Some are in the northern hemisphere, and they will migrate north to their feeding grounds and then back down south to their breeding grounds. Then you have the southern hemisphere populations that migrate south to the Antarctic to their feeding grounds and then migrate back north again to their breeding grounds. Population 11 is the one that's migrating up and down the east coast of Australia, and that's the population that I work on. So just to orientate you, this is the east coast of Australia. If you go up, you'll end up in the Great Barrier Reef, and that's where they breed. And if you go down, you'll end up in the Antarctic, and that's where they feed. About halfway down that map, you'll see Noosa Heads, and that's my study site. So I work on these whales when they're moving southwards towards the feeding grounds, because that's when they tend to socially interact a lot more. Even then, their society has been considered to be relatively simple. And the reason being is they form very small temporary groups and they don't tend to reassociate with each other. So the most common group that we see moving southwards is the mother and the calf. And every now and again, you'll see the mother and calf being temporarily joined by a male. And this male is prospecting for breeding opportunities, because we do know that whales usually breed every 2 to 3 years, but we do have females that tend to breed every year as well. Because as this is the tail end of the breeding part of the migration, males are still looking for breeding opportunities, even with females that have just had a calf. So we call this the mum calf escort group. Now, mum calf escorts can attract other males in, and they will physically compete for access to the female. So the most common group size that we see is 3, but it can get anywhere up to 6 or 7. But this is a very temporary relationship. Males will split off again. And really, we've done a lot of work to determine whether or not these are repeat associations. And the answer is no. They will basically never see each other again. Noting that this is a population of roughly 20,000 whales that are migrating past. So the chances of them running into each other again are pretty slim. While they're moving south, they are competing for access to females. So there is conflict behavior in these humpback whales. And as I said previously, a lot of this conflict behavior is physical interactions. So there's physical competition for the female. So what they do is they'll all join in the female, and there'll be a close assessment of the other males, probably sizing up each other's resource holding potential. You'll have the main primary escort. He'll be the one that's got access to the female. And then you'll have other what's called secondary escorts coming in, assessing him and determining whether or not they can kick him out of the position of primary escort and then become the primary escort themselves. So they're basically moving in and closely assessing each other's resource holding potential. They do have another strategy, which is to sing. I have a question mark there because there's still a lot of debate as to what the function of song is. But as far as I can see, the function of song is twofold. And the first is to attract the female, but the second is a way of passively competing for females. The good thing about song is it allows for far range assessment. So all the males can hear each other, they can hear each other's song, and they can use that as a means of assessing each other's fitness, because there's probably going to be fitness information in that song, such as the size of the male, the body condition of the male, even things like the testosterone levels of the singing male. So when they're assessing each other, or when they're undertaking these interactions, remembering that humpback whales won't be able to see each other very much underwater. So they tend to rely on acoustic communication when they're undertaking these sorts of interactions. And in the slide in the background, I've got humpback whale communication and the search for alien intelligence, because a lot of people find humpback whale acoustic communication really interesting to study, because they make such a vast array of different types of sound. So compared to something like the right whale or the blue whale, they are really, really vocally active, and they have really interesting communicative signals. So in humpback communication, I've already mentioned the song, but they also make a second set of communicative signs called social signs. And social signs are called that just because they tend to make them socially, usually within a group, or when they're trying to communicate to another group that's within range. And they can do this in 2 different ways. They can make surface active sounds, and that's breaching and slapping on the surface. And they can also vocalize as well. So they make what's called social vocalizations. Now, these social signs tend to travel out to about 4 to 5 kilometers from the whale, from the signaling whale, whereas the song can travel up to 20 kilometers away from the singing whale. So the song is extremely loud and travels quite a long way. So it's an excellent broadcast signal. The social signs are a lot quieter, probably travel only out to about 4 to 5K. So very good at communicating within group, pretty good at communicating between groups, but within a shorter range than the song. The humpback whale song has been studied since the 1970s. And the reason being is that it's quite a complex signal, and it's considered to be one of the most complex signals in the animal kingdom. It's a male-only signal, so only male humpback whales will sing, and they predominantly do it in the breeding season. So that's why we think it's involved in a courtship or a sexual display. It's so complex that we think it has to be aimed at the females, but I'm still convinced that there's information in there that other males can hear, and it allows them to assess the fitness of the singer. So although the question mark there is it an inter or an intra-sexual signal? As far as I'm concerned, it's both. It's available to both females and males for them to assess the singing male. Listed there are the 4 different hypotheses of song. As I said, the function of song has still not quite been determined, but what we don't think it is it's got anything to do with the synchronization of estrus, just because they do tend to practice singing on the feeding ground, so that would be embarrassing for the female. And we don't think it's involved in inter-male spacing. We do think it's a mix of female attraction and male dominant sorting. Now, Mike Node, who's a colleague of mine, does a lot of work on humpback whale song, and he suggests that the pattern of song is learnt socially, so it's a form of culture. Each population that you saw in previous slides sings a different song to each other, but all males within each population will sing the same song. So the East Coast Australian whales have their own song, the West Coast Australian whales have their own song, the Indian whales have their own song, and so on and so forth. So the cool thing about whales is that they tend to not stick to one strategy or the other when they're in conflict. They can actually switch between non-singing and singing strategies. So the thing that I wanted to know was, why are they switching from one to the other? And is this an indicator of social intelligence in humpback whales? In other words, are they making strategic decisions? Are these decisions flexible? And are these decisions dependent on the roles of other male competitors within their social environment? So Anna's going to be very familiar with this. In fact, she might even have appeared in one of these photos. I can't really see, but there's Kerry Anna on the theodolite. And this data was taken in 0304. So all the data that I'm going to show from now on was actually collected back in 0304. And what we're able to do is take land-based observations of all our whales as they move southwards down past our site at Perigian Beach, which is just down from Noosa on the map that I pointed out earlier. And what we do is we send volunteers up the hill, and they are there from 7 in the morning to 5 in the evening. And they are taking constant observations of all the groups as they move southwards. Because they're so good at it, they're able to distinguish whether or not the group is a mum calf or just a singleton or a mum calf escort. And they're also able to continuously record their behaviors as they move down the coast. On top of that, we've got acoustic data collection, because obviously we want to know which of those whales are singing. And we also want to know which of those whales are making social signs and what kind of social signs they're doing. So the way that we do that is we moor an array of 5 hydrophone buoys out to sea. Those hydrophone buoys send the signals back in real time via radio waves to a base station that you can see in the photo below. And then using a method that I won't go into here, we do what's called acoustic tracking. And that acoustic tracking helps us pinpoint where that sound is coming from. So if, for example, it was a song coming from a singing whale, we can pinpoint where that song is coming from. We marry that up with the land-based data collection, and we can now say that that singleton in the middle of our study area was in fact the singer. So now we have a picture of our mum calf, our singletons, and a mum calf escort. And we know now that one of those singletons was in fact singing. So he's using the male singing strategy. So for my research, so what I started to do was focal follow individual males and try and determine what was driving the strategic decisions that we were making. So on the right, you'll see that the singing male is encoded in blue, and I've drawn a 5-kilometer social circle around that singing male. And the reason that I use 5 kilometers is because from previous work, I think that they're really concerned with groups within 5 kilometers behaviorally. They tend to ignore groups outside that 5 kilometer zone. And the reason for that is probably that their social sounds travel approximately 5 kilometers. So they can hear all the other groups within 5 kilometers of themselves, but they won't be able to hear groups outside that 5 kilometer social circle. So from now on in this talk, I've coded male singers blue, and males that are choosing to physically interact, I've coded them gray. The other thing that I want to know is what they're doing while they're interacting. So as I said earlier, males will tend to split and join from other groups. Some males will split from a group and leave the social circle. Some males will split and join the social circle. Some males will join while they're in the social circle. And some males will even additionally join other males within that social circle. So what I'm looking at is not only what different strategies that they are using, but what they're actually doing with those strategies. Are they joining other females? Are they joining other groups with other males and then trying to compete for that female within that group? So here we have our singer, and here we have our singer switching to a non-singing behavior. And what's actually driving that switch is two different things. The first thing is the number of other non-singing males within their social circle. And that's the bar, the chart on the left. When they're singing, there's only about 2 other non-singing males within that 5 kilometer social circle. But as soon as more males start to enter that social circle and we get above 2, they will switch to the non-singing strategy. So they seem to be taking account of the number of other males within that social circle. The other thing that they do is they will switch to non-singing behavior if one of those other males starts singing. So not only are they keeping account of the number of other males within their social circle, but they're also keeping account of what they're doing. So if another male switches to singing, that male tends to switch to non-singing behavior. So in summary, if you want to sing, you tend to do it in a low competitive circle with no other singers there. When you switch to non-singing behavior, it tends to be when you have a more competitive social circle and another one of those males starts to sing. So why are they actually doing this? What's the payoff for this? And to do that, I looked at the success of these individuals. And by what I'm saying is the success is the likelihood that he's going to join with a female. Now that's all well and good as long as you don't get joined by other males that are going to physically outcompete you. So I would call that a cost. The success is that you join a female. The cost is that you're going to be joined by other males that could outcompete you for that female. So on this graph, you'll see the total number of males running along the x-axis. And you'll see the score according to whether they're successfully joining or whether they're being additionally joined and the probability of that. And what this graph is showing you that the more males that are within an individual social circle, the less chance or the lower the joining the probability. And this makes sense because there's only a limited number of females that are migrating through. The more there are competitive males within the social circle, the less chance you actually have of successfully joining that female. Not only that, you've got an even greater chance of being additionally joined by another competitive male. So as your social circle becomes more competitive and there's more males within that social circle, you've got more chance, even if you manage to join, of being additionally joined by other competitive males. And if you add those two probabilities up, your payoff reduces. So there's a decrease in payoff as the number of other competitive males within your social circle increases. So what do? Well, a good idea is to switch to the singing strategy. So with the singer, your singer payoff is actually greater than your non-singing payoff, up to 4 males within your social circle. So the non-singer payoff with another singer in the area tends to be quite flat. And the singer payoff tends to be greater than the non-singing payoff up to 4 males. And this is because singing males actually have a way greater joining success than non-singing males. So maybe the females are way more attracted to singing males than they are to physically competing males. But then after you get to about 4, switching to that physical competition strategy has got a better payoff for you. So this then goes back to, if I go back to the original results, this explains why animals will switch from the singing to the non-swinging strategy in a more competitive circle. When the circle is less competitive, you've got more joining success as a singer. When the social circle is more competitive, you've got a lot more joining success as a non-singing whale. But the other thing that I wanted to look at is if you're a resource seeker and if you're a resource holder, does that actually change your decisions? And the answer is yes. If you're a resource seeker, so you're on your own and you're seeking out females, whether you sing or not sing depends on the number of other males within your social circle. Low number of other males, you might as well sing. Large number of other males don't sing. But what they don't care about is whether or not other males are singing. If you're a resource holder, you don't actually care about the number of other non-singing males within your social circle, but you too care deeply about the presence of another singer. So whales will not sing and join a female if there's another singer in the area. So to summarize, is this society of humpback whales so simple after all? We've got strategic competitive decisions. They're being made by males. These decisions are flexible and dependent on other male competitors within their social environment. They'll choose their strategy also depending on the resource context. In other words, whether they're resource holders or resource intruders. And the next part of the talk will explain why males actually switch from this singing to this non-singing behavior when escorting in the presence of another singer. So I've already mentioned the communication space of migrating whales. It's about 4 to 5 kilometers long. You've got your group in the middle and they're signaling to each other, but these signals will travel out to about 5 kilometers. And within that 5 kilometer radius, you might have a singer and you've got other eavesdroppers as well. So you've got other whales that are eavesdropping in on these signaling interactions. So what I wanted to know is, are these groups of whales actually considering these eavesdroppers, and are they changing their communication behavior based on the presence of these other eavesdroppers? And the answer is yes. Groups will actually lower their vocal level in the presence of a nearby singer and in the presence of other eavesdropping whales. And this is called the audience effect. So this adds evidence to the fact that groups are actually considering the presence of other whales within their social circle. When there's a singer within 2 kilometers, they drop their vocal level by 15 dB, by 15 decibels. And that means that their signals will only propagate out to about 1.5 kilometers. And what we think they're doing is they're undertaking what's called vocal crypsis. They're basically hiding from this audible singer. And that makes sense because if you're with a female, the last thing you want to do is attract another male over. So we know now that groups are considering vocally the presence of eavesdroppers, and they're changing their vocal behavior in the presence of other eavesdroppers. Singing whales will also change their behavior in the presence of other whales. Now, the problem with song is that it can propagate up to about 15 kilometers. So that social circle is huge. There's a huge number of other males that can listen in to you singing. So the last thing you want to do as a singer is attract these other males in. So if there's another singer in your social circle, if there are other males that are nearby within your social circle, the last thing you want to do is attract those males in, so they'll stop singing. So that now explains why singers will join females and immediately stop if there's other animals within their social circle. We did have some rule breakers. So animals that continued to sing with other singers and males within their social circle were more likely to competitively join. In other words, they were attracting other males in. Those males would then outcompete that poor singer for the female. And that was basically a fail for that strategy. So we now know that humpback whale society involves frequent and flexible interactions. They choose their conflict strategy according to the other males in their social circle. We also know that they rely on communication for these strategic choices, and they can change their communication to try and mitigate for other animals within their social circle. And we also know that singers consider the presence of other males within their social circle. Now, as I alluded to earlier, they are renowned for the communicative complexity. So could their social complexity actually explain their communicative complexity? So the social complexity hypothesis for communicative complexity is 1, a massive mouthful, but 2, could explain the link between social complexity and communicative complexity in whales. So very simply, an animal with low social complexity, such as your cheetah here, has low amounts of communicative complexity. So the cheetah here has about 6, 7, 8 different calls. The lemurs, on the other hand, are considered to be quite socially complex. And as you can see here, there's a vast array of different types of calls. So I've already explained the social complexity part of the equation with humpbacks, and now very quickly go into the communicative complexity part of the humpbacks. And lots of people want to know, well, all right, that's all well and good, but how do we measure communicative complexity? And there's a number of different ways, and I'm not going to go through the diagram here, but you can see that the number, you can measure the number of different call categories. So category 1, category 2, and so on. Within those categories, you might have different call types, A, B, C, D, E, F. Within those call types, you might have a level of gradation. So one call type might be quite graded and morph and grade into a different call type. You might have call stereotypy across individuals. You might have lots of differences between call types and call categories. And you can measure all of these different facets and come up with a species call repertoire. And then you can start comparing that call repertoire in between species. So if we have a look at different species, everyone's familiar with the dog, and the domestic dog has roughly 9 different types of call. Poor old golden rocket frog has about 3. Surprisingly, the big brown bat has 18, who knew? The walrus, the elephant, and the right whale have 8 or 9. Even the bottlenose dolphin, who is considered to be quite socially complex, has 12. Now the bonobo I've put there because he has a complex, stable social society. And to mediate that complexity, he has 38 different call types. And if you run your eye down to the bottom, you'll see that the humpback whale has roughly 36. So not far off from the bonobo. Now there is a caveat before you get too excited. And the caveat is that the humpback only has about 10 different call types that you hear year after year after year. And the other call types will move in and out of its repertoire. So if we have a look at those common call types that you hear year after year after year, they do have a possible function associated with them. You tend to hear breaching and slapping year after year. You've all been whale, or anyone that's been whale watching will see those humpbacks breach and slap. They are a communicative signal. We think breaching is all about to do with the location of the signaler, big loud bang, everyone else can know where he is, as well as the size. So big whale, big bang, small whale, small bang. Slapping, we think, is a female solicitation call. We see whales slapping and we tend to see animals joining together. We tend to see males joining females when they start slapping the surface. You've got other low frequency calls, whop, whop, grumbles that you hear all the time in stable groups. They're quite quiet. They're probably going to be contact calls between those groups. So groups that aren't undergoing splits or joins. If a group starts joining together, they tend to grunt and produce these grunt chimes. And then you tend to hear high cries, underwater blows in competitive groups where the males are fighting. And sometimes instead of singing while they're joining, they tend to use little chunks of the song called song units. And again, we think that's a sexual signal directed at the female. So these are the sorts of common signs that you'll hear year after year after year, but only accounts for the small proportion of the humpback repertoire. Another part of the repertoire is what's called graded, and that accounts for another proportion of that repertoire. And what graded means is that call types tend to morph and change into different call types. So then it becomes really difficult to try and separate them up. Here you'll see a number of different calls, and you'll see spectrograms of a number of different calls. And along the bottom, you've got those grunts and grumbles and thwops that I mentioned earlier. But as the groups tend to be more excitable, as you'll see males coming in and competing with each other within these groups, grumbles start to morph into growls. Growls start to morph into screeches, and screeches start to morph into screams. So these calls become increasingly difficult to separate from each other. The reason for this is that motivation tends to be coded in these graded calls. So an aggressive call is very harsh and very low frequency, just like your growl, your screech, and your underwater blow. And as they become more fearful and as they become more appeasement type calls, they tend to then develop into the fear endpoint, which are your descending cries, your squeaks, and even your scream, which are more like a distress call. So what was happening here is we probably got some stable sound types like your contact calls, your joining calls and things like that. But within those calls, you also have motivational signals being encoded in there. Am I being aggressive? Am I being fearful? So within the mum-calf groups that aren't joining, you'll hear your grunts, your grumbles, and your thwops. But within those competitive groups, you'll hear a lot more different call types, and those call types tend to be graded, probably signaling both aggression with your primary escort and fear with your secondary escorts that are being battered by that primary escort. So to summarize, social complexity seems to go hand in hand with the communicative complexity in humpback whales. However, I've defined social complexity quite different to those stable groups and quite different again to those fission fusion groups. Within those stable societies, you want to keep up with who is friends with who and who will win against who. And those socially complex relationships do require a vast array of different signal types. Within the humpbacks, it's slightly different. Here, you're trying to keep up with the neighbors, and those neighbors are constantly changing. You constantly have different males moving in and out of your social circle, and you've got to keep up with that, and you've got to mitigate for that. So in the bonobo, we've got those stable societies where you have who is friends with who and who is fighting with who, with 38 different call types to mitigate those interactions. And the humpback whale, you've got the neighbors. You've got different males moving in and out of that social circle. They've got to constantly keep up with these neighbors. They've got to constantly assess each other's resource holding power. And again, seems to be a similar number of signal types within their repertoire. That's it from me. I just want to do a shout out to Associate Professor Mike Node and Doug Cato, who Anna knows. They've led that earlier fieldwork where a lot of this data came from. Since 2003, we've had almost 200 participants in this collaboration over the last, and I'm not going to say how many years, but lots and lots of years. And then I'll just acknowledge my funding agents as well.